So this topic is the interconversion of prefixed and base SI units. So you may have met this before and be like, oh yeah, you just got to times it by 1,000 or divide it by 1,000 or whatever. So first of all, I want to show you what I mean by an SI unit prefix. So a prefix is basically indicating the order of magnitude of your unit. So we use them a lot in chemistry and other sciences. You can roughly divide them into big things. So that's when you've got a positive exponent for the power of 10, or small things, or technically subunits, where your power of 10 is a negative number. So that's 0.00 blah, 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 whatever. Okay, so ones we use a lot in chemistry, we come across kilo quite a bit. Sometimes we're talking about frequencies and stuff. You'll come across like mega, giga, tera. But with chemists, we deal with atoms, so you're mostly looking at small stuff. So deci is used a lot, particularly in Europe, for concentration measurements and volumes. They use deciliters quite a lot. Centi is used a lot. Okay, if you're familiar with a centimeter ruler, and milli. Milli we use a lot in the US for volume measurements, and micro, okay, for concentrations, etc. And then when we're actually sort of getting down nearer an atomic scale, we use nano, pico, femto a lot. And I really want to draw your attention, as I'm a solid state chemist, to the angstrom. Okay, so the angstrom's got this great symbol, the A with a little circle at the top. I know there's a name for it, but I've forgotten it. And that is 10 to the minus 10 meters. So that's very convenient because that is on the scale of magnitude of unit cell lengths in solid state structures. So we tend to use this quite a lot. So those are the ones that I really want you to know. Okay, those are the really important things. So when we are using SI units, prefixes, and interconverting between them, these scientific notations of the order of magnitude you can use as an equivalency. So what do I mean by an equivalency? That is having two different sets of units where that quantity is equal to each other. Quantity given in two different sets of units. I like to use this approach because it helps you with dimensional analysis a little bit later. So for example, I can take from my SI unit prefix table, I want to know how many centimeters are in a meter or whatever. So I can write 1 centimeter equals 10 to the power of, sorry, it's difficult to type, minus 2 meters. So that is how we would write an equivalency based on knowing what our prefixes were. Or if you're talking about big stuff, I could say 1, let's say gigahertz, just to be fun, is equal to 10 to the power of how many hertz? 9 hertz. So that is an equivalency between those two sets of units, prefixed and based, okay? And then you can use it to make a unit conversion factor, which is using one of these as a fraction to convert from one set of units to another. Equivalency as a fraction to multiply quantity by blah, 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 to convert between unit systems. So I know this seems like a long-winded way about going about it, but if you take this approach from the get-go, it makes things a little bit easier as you progress. Okay, so without further ado, where is the question? Haha, it's hiding. Okay, so this is, we have to convert between kilograms and grams. So the approach I say is to know your common SI unit prefixes and then write out an equivalency. So 1 kilogram equals exactly 10 to the power of 3 grams, because that is what the prefix kilo means. So now I have my equivalency, I can use it to perform the conversion. And that way you're not being like, is it times by 1,000 or divide by 1,000? That's a 50-50 coin flip you don't want to get wrong, right? Otherwise you'd be 6 orders of magnitude out. So 1 kilogram times, and then my unit conversion, you want to have the units on the bottom you want to get rid of. So I always teach, just write the units first and don't care about the numbers, and then we'll fill the units in later. So I want kilograms on the bottom so it cancels, grams on the top. Okay, so then I take my equivalency and just write those numbers with the units they go with straight into that unit conversion factor. So 1 kilogram is exactly equal to 10 to the power of 3 grams, or 1,000 grams if you prefer, right? So let's turn that into an actual fraction by drawing a line. So this is the sum that we are going to do. So hopefully you guys can agree kilograms is going to cancel out, and then I can just check that in my calculator. Now, we weren't asked for 1 kilogram. We were asked for 6.9967 kilograms. I kind of got carried away there with the unit conversion. So what we would do is write 6.9967 kilograms and then multiply that by 10 to the power of 3 grams over 1 kilogram. Okay, so we assure that everything is cancelling out correctly, and we should end up with, if you stick it in your calculator or just do it in your head, I don't mind, 6,996.7 grams. So we've just switched out our units essentially for that quantity. Okay, makes sense. So let's look at another one just to make sure we've got the hang of this. So let's show another one. Give me something small. Oh, okay, micrograms. Okay, so micro and milli is the thing I see chemists confusing the most. Magic disappearing coffee cup. Okay, so micro is the funny one with the mu symbol. So it looks like a U with something attached to it. I'm going to try and draw it prettily, but we'll see. So this is mu for micro. Kind of looks like that, right? U with a little tail on it, okay? And that equals micro, which is 10 to the power of minus 6, okay? Micro, 10 to the power of minus 6. Milli is 10 to the power of minus 3 and has the little M symbol. So I can write an equivalency that I'm going to just write a U to make it easier. Microgram is equal to 10 to the power of minus 6 grams, right? So micro is a small thing. So then I can convert this into a unit conversion factor to do my equation. So 3.428 times 10 to the power of minus 5 grams. So I want the grams to cancel out. So in my unit conversion factor, I am putting grams on the bottom, so it cancels, and micrograms on the top. So that is what I am left with. Okay, so I know from the equivalency I just wrote that 1 microgram is equal to exactly 10 to the power of minus 6 grams. Be careful when you're putting stuff like this in on your calculator. Get to know your calculator. It may have certain requirements for what you need to put in parentheses and stuff, and you might have a special minus button for when it is a negative number versus the operation of subtraction. Okay, so just watch out for that if you're putting that in your calculator. So 3.428 times 10 to the power of minus 5 divided by 10 to the power of minus 6. Oh my goodness, I don't have my calculator with me. It's going to be like, oh, do I have to do this in my head? Times 1, 2, 3. It's going to be many. So, let me pause this a second. I'm going to go. So the way I would put this in my calculator, it's going to be just, oh, it's 5 minus 6. That would be like 34. But I would open bracket and type in the 3.428 times 10. My calculator has a y to the x button, so I'd push that. If I'm worried about the negative exponent, I'd open bracket and I'd hit the plus/minus button that I have, which is not next to my plus, minus, divide, times buttons, right? Somewhere else, minus 5, close brackets, and then close brackets again, and then times 1 divided by open brackets, 10. I've got y to the x button to the power of minus 6. Sometimes you might have to write 6 minus, right? So it depends on your calculator. So yeah, I get 34.28 micrograms. Where is my, there we go. 34.28 micrograms should be the answer. Okay. So just make sure you know those common SI unit prefixes, write an equivalency, and then use that to make a unit conversion factor to convert whatever your value is in base units or prefix units to whichever one you're trying to get to. All right.